Hey everyone, welcome back to another session in IBDP MAI HL. In this session, we will discuss paper 3 question on topic 4 statistics. Okay, so I'm going to use the TI Inspire CX2 calculator for the calculations. Okay, so here is the first question. It says two IB schools A and B follows the IB diploma program but have different teaching methods. So a group of 8 students were randomly selected from each of the school and provided a standardized test, and their marks obtained are noted down, and then later they are compared with the final IB points. Okay, so based on this, our first question is identify a test that might have been used to verify the null hypothesis that prediction from the standardized test can be modeled from the normal distribution. Because see, our standardized test and the final IB points can be modeled by normal distribution. So here we can use chi-square goodness of fit test. Okay. Next question. It says, state why comparing only the final IB points of the student from the two schools would not be a valid test for the effectiveness of the two different teaching methods. Here you can write your answer in your own words. There are various answers to this question. Okay. So like you can say, because our aim is to measure the improvement, right? Final improvement. That should be our aim. And you can also say the students may be of a different ability in these two different schools. So because of that one, it is not a it says it is not a valid, right? It would not be valid test for the effectiveness of the two different teaching methods. Okay, next one. Question 3. It says this data is given corresponding to predicted IB points, means from that standardized test, and the final IB points obtained at the end of the year. Now it says for each student, the change from the predicted points to the final points was calculated. So we have the final points, we have the predicted points. We can take the difference of these, right? F minus P to get the changes. So I'll start from here. Now the first part says C1, find the mean change and also find the standard deviation of the changes. So we have to answer for these two changes. Okay, mean change as well as standard deviation of changes. Again, it means we have to apply our one variable statistics to change column. First we will calculate the changes that we can do with the GDC directly. Okay, so 44 minus 43.2, which is 0.8, will appear over here, but I will use a GDC for this one, and I'll explain step by step how to get that. Okay, so in your GDC, go to home page, then select spreadsheets. Okay, here in this column 1, this is our column 1, or I'll call it A. Write down the predicted marks over here, and in the column B, write down the final IB score. So it looks like this. Now in the column C here, over here, from this cell, you can go to this cell, and we need the difference from the final and the predicted. So I will use equals, this is B1 cell and this is A1 cell, right? So I will use equal B1 minus A1 and hit enter like this. Once you hit the enter, you will get the difference, which comes out as 0.8. Now you can drop this, drag this and drag it, and you will get the column, this third column, C column, as the change, like this. Now we have, remember, in the column C, I'm writing all the changes. Okay. Then after this, after doing this, we need to do the one variable statistics on column C only. So go to menu, then statistics, stat calculation, and one variable statistics. So we are doing our calculations on column C elements only, means changes which are present in column C. So change it to C column. Frequency is 1, keep everything as it is, and our answer will appear in the column D. So here is the result. We got the mean as 0.1875. So we got the mean change. What is that? 0.1875. And also we have to find the standard deviation of the changes. Standard deviation is over here. This one is population standard deviation. And this one, which is above to that, is sample standard deviation. But we need population standard deviation here. So the answer to this question will be 2.46091. And you can round off your answer to three significant figures, okay, to get the values. Next one. Next part is for the same scores, right, predicted and the finals. It says use a paired t-test to determine whether there is a significant evidence that the students in the school A have improved, right, their IB points since the starting of the course. And we have to do it for 5% significance level. So we have to determine whether there is a significant evidence, right, or not. It means we have to use our t-test here, okay. But t-test on what? Changed, right? Changed values. So let's go back to the same spreadsheet that we used earlier, okay? And our null hypothesis is what? There is no improvement. And H1 will be that there will be an improvement. Okay? First, we need to make these hypotheses. Now, in your GTC, go to stats, then stat test. After that, select t-test. Now, after the t-test, it appears like this. Since this time we have data, okay, this time we have the data, so we will enter data in here. And starting with this one, mu naught is what? 0. Why it is 0? Because we are considering that there is no improvement, means changes is 0, okay. And mu, which is going to be the mean value of the changes here, mean of these values will be mu. So our elements are in C column, frequency 1, and we are trying our, what is our alternative hypothesis, that there is change, there is improvement. It means this mu will be more than mu naught, right? Mu is what? Again, it is mean change, the mean of the changes in final and predicted points. Our result will appear in F column. Just hit enter, you will get the results like this. Now, p value, we need this p value. What is the p value? 0.42. 0.42298 is the p value. And we have to compare it with what? 5% significant figure level, right? So our p value is 0.422988, which is obviously more than 0.05 because we have to compare it with 5% significance level. So this value is more. It means we can say there is no significant evidence that the student has improved, right? So that's the answer. Okay. Now, we always have to compare p-value with the significant level. Okay. Next one. Now corresponding to second school, school B. This time they are not providing their predicted data and the final data. They are just providing the change. This time we will make another column and write the change in final and predicted IB points for the school B, okay, in the same spreadsheet. Now, question says, use an appropriate test to determine whether there is an evidence at the 5% significance level that the student in the school B have improved more than those in school A. So this time we have to compare them for the school B and school A, right? With respect to their improvement from means changes. So we have column C, right? You remember in our spreadsheet, we entered changes in the school B score in the column C. So I'll make a new column for the B school as well. Okay. Our null hypothesis is that there is no difference between these two schools. And yes, our alternate hypothesis will be as given in the question, school B have improved more than school A. So school B did better than school A will be our alternative hypothesis. Now let's find the p-value and compare it with 5% significance level. So I will use one-tailed two sample t-test in this, right? So one-tailed why? Because we are trying to find whether mu2 is more than mu1 or not, right? Whenever you have to use like this, mu1 greater than mu2 or this, these are one-tailed tests. But if you have to check whether mu1 is equal to mu2 or not, in this is called two-tailed, right? Okay. Now go to GDC and enter the changes in scores for the school B in the column H, and remember this, okay? So I'm entering all the values over here in the column H. Now I have to compare column C and column H, okay? So for that, go to statistics, stats test, and then select two sample t test. We have the data, okay? We already have the data values in C and H columns. So click on data, hit enter. So list 1 corresponding to this, the mean will be mu1. List 2 is corresponding to school B and mean will be mu2. Mean in the changes, right, of the marks. Frequency is 1 1 for both. Our alternative hypothesis, as I said earlier also, that mu2 is greater than mu1 I have to select, because mu2 is corresponding to B school and mu1 is corresponding to A school. Now hit enter or click OK, and it gives you p-value as 0.099308. Again, if you see, 0.099308 is again more than that 0.05. So there is no physical significance, right? There is no physical evidence to reject the null hypothesis. So hence the solution. Okay. So we do not reject the null hypothesis basically. Next part. Next part says, state why it was important to test that both sets of points were normally distributed. Okay, state why it was important to test both sets of points were normally distributed. So here again you have to write your answer in a statement form, that you can say sample too small for the central limit theorem. That's why we have to apply this t-test, because the t-test assumes the normal distribution. Okay, answer. Next one. Now, here we have for the school A, their marks obtained in the that standardized test, final exam, as well as efforts and average effort score made by the each student for school A. Okay. So this time it says it is claimed that effort put by the student is an important factor in improving their predicted IB points. So now this time again it says perform a test on the data from the school A to show it is reasonable to assume a linear relationship between effort score and improvement in IB points. So we have to check whether there is a relation between these two or not. So we will use a, here it is clearly mentioned that use a linear relationship. It means we will use linear regression for this, right? And we will apply our linear regression t-test to get this. And we can find the p-value as we did earlier also, right? We will find the p-value and we will compare it with the 5% again this time. Okay. So let's find the p-value and compare it with the 5% significance level. Here, first one, null hypothesis is that rho is 0 and it is greater than 0. Means we will consider that there is a linear relationship between the effort score and improvement in IB points is there or not. So we will consider our null hypothesis and alternate hypothesis like this. After that, go to your GDC and enter all the effort, average effort scores in the column K. Okay. So I'm writing all the values in the column K. So now go to statistics, then stat test and select linear regression t test. Okay, we have to find whether there is a linear relationship or not. So linear regression t test, where we'll get the p value also. Now X list changes. You remember we entered all the changes in the score in the column C. So it's here, and efforts in column K. Here we have efforts, and for the X we have the changes in the score. Now our alternative hypothesis is that P greater than 0. Hit enter, it gives you the results like this. So here we got the p-value as 0.001569. So this time our p-value is less than that 5% significance level. So 0.01569 is less than 0.05, right? So this time we can reject the null hypothesis. So we can say that yes, there is a significant evidence for the linear correlation between the efforts and the improvement, right? Now, we always have to compare with the p-value if they are providing the significance level. Sometimes they provide the chi-square critical value, then we have to compare it with that only. But in this question, it is not provided. Next one. Next question is School A also gives each student a score for effort in each subject. This effort based on the scale of 1 to 5, again same thing. Now the question says hence find the expected improvement between the predicted and the final points for the increase of 1 unit in effort grades. So what is that? We already calculated it in our linear regression t-test. Go back to that. Okay, here this part b, right? B, what is that? It is actually gradient, right? A plus bx was the linear regression equation. So this value is the gradient, and this is our answer, right? Gradient is what? In this case, you can say 6.6 will be our gradient of the line regression, and also it is the expected improvement between the predicted and the final points for the increase of 1 unit in effort grades. Okay. Now, after this, next part is a mathematics teacher in school A claims that the comparison between the two schools is not valid because the sample for the school B contained mainly girls and that for a school A mainly boys. So she believes that the girls are likely to show a greater improvement from their predicted points to their final points. Again, we have to test this one. So what is given to us? If the changes F minus P's final minus predicted grades is less than -2, for male 6, for the females it is 3. For the change -2 to 0, this is the data. Change is 0 to 2, this is the data. Change is more than 2 is this data. Now, if you observe carefully, here we have 3. What that means? When average is less than 5, then we always merge that column with its adjacent one. So in this case, we have to merge these two. Okay, instead of doing it as two different column, we will write it as f minus p lying between what, uh, less than 0 basically. Okay, less than 0. For this one we will have, for male it will be 8 plus 6, which is 14, and for female it will be 8 plus 3, 11. So we have to replace our these two columns with this column. Okay. Now, use an appropriate test to determine whether showing an improvement is independent of gender or not. Okay. So, first of all, as I said, we will consider the null hypothesis as improvement and gender are independent to each other. And null hypothesis is improvement and gender are not independent. They are depending on each other basically. Okay. So, our null hypothesis is always like there is no change. Okay, things are independent like that. So as I said, make the new table and we will use chi-square test of independence because we are checking whether these are independent or not. So chi-square test of independence will be used over this new table. Here f minus p is 14 and 11, as I said, by merging these two columns. Now you can enter or you can create a matrix basically for finding this chi-square test of independence. Make a matrix of 2 row, 3 column. Okay. For that, go to normal calculation mode, then menu, then matrix, and select create matrix of order 2 by 3, 2 rows, 3 columns. Okay. That shows you like this, and now you can enter all the values over here, like 14 here, 14, 10, 9, 11, 14, and 8. Once you enter all these values, it looks like this. Now you have to store this matrix. So in your GDC, press Control and Store button, which is var variable button. Okay, just above to 9. So Control and then Store. That shows this arrow, and you can store this matrix with any name. So I'm calling it V. So V and hit enter. Now whenever you write V, automatically this matrix will come into picture. Now we have to use chi-square test of independence over this matrix. So go to menu, then stat test, and select from the stat test, select chi-square two-way test. We already have our observed matrix, so you can click on this drop down menu button and it shows the following. So we have to select the V, right? Our observed matrix is V matrix, and once you hit enter, it gives you this table over here. So degree of freedom is 2, p-value is what? 0.58. P-value is 0.58. Now again compare it with the 5% significance level. Okay. Generally we compare it with 5% significance level. Otherwise they will provide you the data whether you have to do it for 1% or 10% or okay. So now our p-value is 0.581, which is obviously less than, sorry, more than 0. Which is more than 0.05. So do not reject the null hypothesis, right? Do not reject the null hypothesis, or you can say no significant evidence that the gender and the improvement are dependent. Okay. So that's our answer to this question. Next one. It says, if you were to repeat the test performed in the part E, intended to compare the quality of teaching between two schools, suggest two ways in which you might choose your sample to improve the validity of the test. Here you can write your answer in your own words, as I said. For the E part, you have to compare. Okay. So you can say either large samples or includes data from the whole school, or take equal numbers of boys and girls in each sample, or have a similar range of abilities in each sample. Okay. So these are various answers that you can write. Okay. So in this way, you can finish a paper 3 question, right? This time it was the 27-mark question. So we are done with this question now. So I hope you got all this. And if you still have any confusion related to this, feel free to connect with me. And for one-to-one tutoring session or regular courses, you can contact me on this number. Okay. And we can discuss the questions with you. So that's it for today. Thank you for watching this session. See you in the next part. Keep watching, keep learning.